All right, so we're going to be talking about compound inequalities. And when we talk about compound inequalities, what we need to do is we need to first look at a form of algebra that's referred to as Boolean logic. Boolean logic is the kind of algebra that computers use, that search engines use. It's kind of a very specific way of thinking. And there's kind of a couple of main topics in Boolean logic, main key phrases that we're going to be looking at. The first of which is the term and the second of which is the term or. And these are really important terms in Boolean logic. So the way Boolean logic works is when a question is posed, the answer must be either true or false, not 5, true or false. So Boolean logic asks a question, the response is true or false. Best example I can give of this is if I was to ask the class, are you 13 or 14? Most of you would respond with your age. I'm 14. However, that's not what Boolean logic is asking. Boolean logic is asking, are you 13 or 14? And your answer would be yes, you are, true. So are you 13 or 14? Your response would be true. Yes, I am 13 or 14. You asked a question, is this true or is that true? And your answer is yes, this or that is true. As opposed to an and designator, if we were to ask, are you 13 and 14? Your answer would be no, because you can't be both 13 and 14 years old. That's not how that works. So in the or case, we're looking at one of the things being true. And this is at least one of the things is true. So we have one is true. And in the case of and, we have all are true. So if I said, hey, are you taller than 5 feet and older than 12? You would say, yes, that is true. I am taller than 5 feet and I am older than 12. Now with or, are you taller than 12 feet or taller than 12 feet, older than 12 or taller than 5 feet? Yes, you are, at least one of those is true. Now, there are such things as exclusive or, where it says or but not and. And then there's another thing in Boolean logic which is not, are you not this? At which point your response would be true. I am not that. So, for example, if I asked you, are you not 11 or 12, right? Because you are not 11 or 12, then you would respond true to that because you are not 11 or 12. However, are you not 13 or 14? You would respond false to because you are 13 or 14. And so we're going to use Boolean logic in order to work with these compound inequalities. And it's really important that we understand kind of how the basic logic works first before we go ahead and try to jump into actually solving any of these inequalities. So the first thing we're going to look at is and, when we're dealing with an and inequality. And there's a couple of ways that these are frequently written. Which an example of this might be -2 is greater than or equal to x minus 3, which is greater than or equal to 4. Or less than or equal to 4. So this is setting up multiple things that are true. It is saying both -2 is less than or equal to x minus 3 and x minus 3 is less than or equal to 4. So this is saying two different things that are true at the same time. And so we can go through the process and solve this just like we have been, where we're going to add 3 to each side here, add 3. And that would give us here that x is, or in this case, this will be 1 is less than x. So 1 is less than x. We could turn that around and say x is greater than or equal to 1, right? 1 is less than x. And then over here, we're going to do the same thing. We're going to add 3 to each side. And what we're going to see is that x is less than or equal to 7. So we've kind of set up this bound here where overall our answer to this would be 1 is less than x, which is less than 7. So what does this mean? Well, x is a number between 1 and 7. Now, we could go ahead and graph this if we wanted to, and I don't have the handy number line I had before, but we can get an idea of what this might look like if we just draw a number line right here, and we've got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we've got 0 right here, 1, 2, 3, 4, 5 right here, 7, 8, 9, 10 right there. And so in order to graph this, we're basically saying, hey, x can be any number so long as it is between 1 and 7. So we would put our dot right here, and this is a filled in dot because we are it does have the equal to sign right here, right? We got that right there and right there. So that's a filled in dot, and then we're going to go up to 7 right here. And we're going to fill in the dot over here as well. Okay, so this is how an and compound inequality works. Now, something different, if we were instead looking at an or compound inequality, if either of these things, if this was this is true or this is true, it turns out x could be any number. Because if this is true, this goes basically, this that we've graphed right here, starts here and goes all the way this way forever. And this that we've graphed right here starts right here and goes this way forever. So what we'll notice is right here is where they are both true, right? This is where and, right? This and that is true. As opposed to if it was or, any number would work because they would meet one of these two criteria. But this equation right here, the way it is written automatically as an and equation because it states these two categories. An or equation would look different, and usually it would just use the word or. And that's how we go ahead and graph inequalities, compound inequalities, where there's more than one thing happening at a time.